Hello class, I'm going to discuss open methods. We have already finished the bracketing methods, which are the bisection method and the false position or the regular falsi. Now let's proceed to the open methods in finding the roots of equations. The first method under the open methods is the simple fixed point iteration. So in the simple fixed point iteration, this is the algorithm. For the step 1, arrange the given equation into the form x sub I plus 1 equal to g of x sub I. Step 2, solve for the approximate error epsilon sub a. So the formula for the approximate error epsilon sub a is x sub I plus 1 minus x sub I over x sub I plus 1. Of course, take the absolute value times 100%. So this is just the same with the calculation of the approximate error for the bisection method and the regular falsi. So there, instead of using x sub I plus 1, we wrote xr new minus xr old over xr new times 100%. So this is just the same with this formula. So new minus old over new. So for this step 3, iterate until the approximate error is less than or equal to the stopping error or the epsilon sub s. For the example, let us solve this problem here. Okay, for the sample problem 1, using simple fixed point iteration, determine the root of f sub x is equal to 2 sine square root of x minus x. Use an initial guess, x sub 0 equal to 0.5. Iterate until epsilon sub a is less than or equal to the stopping error 0.001%. So as you can remember, the step 1 in the method simple fixed point iteration is you arrange your equation so that what is left in the left side is only x. So for the solution, f of x is equal to 2 sine square root of x minus x. So since we are asked to solve for the root, you set f of x equal to 0. And then you transpose the variable x. After that, you put the subscript I plus 1 and I. So you write this equation into the form x sub I plus 1 is equal to 2 sine square root of x sub I. So we have already arranged the given equation. So our equation now for the iteration is x sub I plus 1 equal to 2 sine square root of x sub I. Now let's proceed to the iteration. So compared with the bisection method and the false position method, the simple fixed point iteration table will just be composed of 3 columns, as you can see here. So the first column is I. Next is the value of x. Next is the value of approximate error. For the first iteration, what will be the value of our x? So remember, class, once you encounter problems like this, which contains the trigonometric functions like sine, cosine, tangent, cotangent, secant, and cosecant, set your calculator to region mode. So set your calculator to region mode, because if it's not in region mode, you will get the wrong answer. So always don't forget to set your calculator to region mode. Okay, so let's solve for x here. Our x sub 1 So for our x sub 1, x0 plus 1 is equal to 2 sine square root of x sub 0, or x sub 1 is 2 sine, the value of x sub 0 is given, which is 0.5. So x sub 1 is 1.299274. So the error for the first iteration, so since we have already an initial guess of x sub 0, and this is already the first iteration compared with the bisection and regular fallacy, in the first iteration here, meron na tayong approximate error. So our approximate error is x sub 1 minus x sub 0 over x sub 1 absolute value times 100%. So our error for the first iteration is 1.299274 minus 0.5 divided by 1.299274 times 100%. Times 100 is 61.517%. So just write the values of x sub 1 and approximate error for the first iteration. So 1.299274 and 61.517%. For the second iteration, same process, but instead of substituting 0.5 in this equation, you're going to substitute. So you're going to substitute the previous x, no? So how is that? So let's erase this one here. Okay, so as a sample calculation in every iteration, for your x sub 2, so this is x sub 1 plus 1, 2 sine square root of x sub 1, or this is x sub 2 is equal to 2 sine. So what is the value for x in the first iteration? So this is 1.299274. So we have 2 sine square root of 1.299274. So the value here is 1.817148. So paulit-ulit lang yun sa class until such time that your approximate error is less than or equal to 0.001%. So I will just fill in this table here. So for your third iteration, 1.950574. For your fourth iteration, 1.969743. For your fifth iteration, 1.972069. For your sixth iteration, 1.972344. For your seventh iteration, 1.972377. And for your eighth iteration, it's 1.2381. So let's try to solve the approximate errors. Actually, I have already solved this problem. So this problem has only 8 iterations. So let's see if we have solved the value of x properly. So let's try to solve the errors. 1.8171 for 8 minus 1.299274 over 1.817148. So this is 28.499%. Next, let's solve the error for the third iteration. So this is 1.950574 minus 1.817148 divided by 1.950574 times 100, 6.840%. Next, 1.969743 minus 1.950574 over 1.96974 times 100, so 0.973%. Next, 1.972069 minus 1.96974 over 1.972069 times 100%, so 0.118%. Next, 1.972344 minus 1.972069 over 1.972344 times 100. So this is 0.014%. Remember, we will stop the iteration once our approximate error is less than or equal to 0.001%. So for the seventh iteration, we have 1.972377 minus 1.972344 divided by 1.972377 times 100. So this is 0.002%. Next, for the eighth iteration, we have 1.972381 minus 1.972377 divided by 1.972381 times 100%. So this is 0.0002%. So since the approximate error now in the 8th iteration is less than 0.001%, we will stop after the 8th iteration. And since yung root naman ang hinahanap, our final answer will be the root x is equal to 1.972381. So try to understand this problem. Actually, the simple fixed point iteration is a lot easier. Mas madali siya kaysa sa bisection and false position. As you can see sa table pa lang, we have only 3 columns. First column for the iteration, second one for the root x, third one for the approximate error, and that's it. So, ang iba lang dito compared sa 2 methods na nauna na discuss is you just manipulate or arrange the equation. So, kung mali yung pag-arrange ninyo ng equation like this, so dito na part tayo nag-arrange ng equation. Pag mali yung pag-arrange nyo ng equation, mali na rin lahat. So, be careful in arranging your equation. And also, may mga problems tayo sa exam na hindi given ang equation. Kayo mismo ang gagawa. So, be careful din sa paggawa ng equation kasi dyan nakasalalay si simple fixed point iteration.